Welcome back, children. We are going to start today with our geography lesson of Standard 7, Chapter 3, Our Changing Earth. Children, you must have always wondered and questioned yourself, how did the Earth evolve into the planet that we inhabit today? How did these continents form? How did these oceans form? Yes, let us look into the answers of these questions. Children, in 1915, a scientist named Alfred Wegener, he came up with a new concept of a theory of continental drift, how the continents moved. So we'll study his theory and understand the theory of continental drift. Now, children, according to Alfred Wegener, millions of years ago, all the continents were joined together. It was one big landmass, okay, or a supercontinent. All the land pieces were joined together, and it was called as Pangaea. Pangaea meaning all land. So, according to him, when the earth was born, there was only one big land mass. Okay, it is not the continents that you see today. It was only one big land mass called Pangaea. Children, with time, the supercontinent Pangaea broke up into two pieces. You can see two pieces. In the north, it was called as Laurasia, and here in the south, was called as Gondwana land. Now, with time, these two huge land masses, which were broken up into two parts, also started breaking up further, and they started drifting away from each other. Children, in this slide you can see how the landmass Pangaea broke up into two, and then into Laurasia and Gondwana land, and again how the Gondwana land and Laurasia again broke up into further pieces, and how the continents started drifting away from each other. You can see the visuals. You can see the first scene, how it is closer and getting further and further away, further and further away. Finally, it has taken the shape of our present day continents. So you can see, children, the big land masses which broke away from the Pangaea, then they became into two parts, and then they further broke down, and today we see these pieces are continents formed in the present day. We can see which are the continents which are formed. You can see here North America, South America, Africa, Europe, Asia, Australia, and down below we have Antarctica. So these were formed from Pangaea, okay, because the continents have drifted away with time. So you see, children, as the continents drifted away, okay, so in between these land masses, water got collected and they formed our oceans. So we see the formation of Pacific Ocean, Atlantic Ocean, Arctic Ocean, Indian Ocean, okay. So this was the theory of continental drift that was given by Alfred Wegener. Children, many did not believe in the theory of continental drift that was given by Alfred Wegener. People said that it is not possible that the continents have drifted, but one example that you can give which proves that his theory is correct, if you can see all the continents can be joined together like a jigsaw puzzle. For example, if we see South America and Africa and we bring them closer, they fit exactly like a jigsaw puzzle. So that proves that his theory was correct. Children, after the theory of continental drift, we find yes, the continents have drifted apart, but another question that arises in our mind is, why did the continents break up and drift away from each other? Yes, so we are going to now learn about a new theory called theory of plate tectonics. What is the meaning of tectonics? Means to build. We are going to learn why the continents broke up and drifted away from each other. What was the major reason for this? So let us look into and find the answers of this theory of plate tectonics. Now children, to understand the theory of plate tectonics, we must recap whatever we had learned in our first chapter, Inside the Earth. Now what did we learn in our first chapter? We learned about the layers of the earth. So what are the layers of the earth? The first, which is the thinnest and the hardest layer of the earth, is the crust. Okay, below that we have the mantle, which is in a semi-liquid state. Then we have the outer core, which is again in a molten state, and the inner core, which is in a solid state. Okay, now let's look at this picture here. Okay, so the crust comprises of the continental crust and oceanic crust. Under the ocean also there is hard layer. Okay, then we have the next layer, as I told you, it's a mantle. Now mantle is again further divided into upper mantle and lower mantle. Now you can see the upper mantle, there are two lines. Now this small portion of the upper mantle is in a solid state. Okay, it's hard. So the crust and the small portion of the upper mantle forms the lithosphere, that is land. Okay, and below this there is a semi-liquid state which is called as a asthenosphere. Now this lithosphere land is broken up into pieces which is floating on the asthenosphere, and this asthenosphere is in a semi-liquid state. Children, to give you a better understanding, look at this diagram. You can see here, this is the asthenosphere, as I told you, is in a liquid state, semi-liquid state. And then you can see here the lithosphere, which is the crust, and the upper portion of the mantle, which is called as the lithosphere. Both are now floating on the asthenosphere, and this lithosphere is broken up into pieces. Okay, so this diagram clearly shows you how the lithosphere is floating on the asthenosphere. Now children, our Earth's crust is not one solid sheet. It is broken up into 12 main plates. You can see, and if we join these plates, they fit each other like a jigsaw puzzle or like a puzzle piece. And these plates are called as lithospheric plates. Children, as I told you, our Earth's crust is broken up into pieces and it is floating on the mantle, which is in a liquid state. And to give you an example, how is it floating? You can see here, this is a picture of a soup, and on top of that we put crackers. If you take tomato soup, don't they put breadcrumb pieces over it? So the bread pieces are like our Earth's crust, and the soup is like the mantle, which is in a liquid state. So children, the lithosphere is broken up into a number of pieces, and they are called as plates, or they are also called as lithospheric plates or tectonic plates. Now we learn about the theory of tectonic plates. Children, the circular movement of the molten magma inside the earth causes these tectonic plates or the lithospheric plates to move slowly. So you can see here the molten magma, the circular convection currents, yes, circular movements. This causes the plates to move. Now let me explain to you in a better way by showing you an example. Children, now let me show you how the molten magma inside the earth makes the lithospheric plates or the tectonic plates to move. So let's take an example. Here I've taken a beaker which is filled with water and put on the gas on the other gas burner, and I will let the water boil. So you see, when the water boils, what happens? The bubbles come up, move down, again they go up, again they come down. Okay, and after the water boils, we will crumple a piece of paper and put it inside this beaker. What do we see after some time? We see that this paper is floating and bouncing on this liquid, okay, on the water, and after some time, yes, the paper sinks down. Okay, so this is how because of the convection currents, these heat currents make these lithospheric plates to move. Now look here, is a soup again. Okay, So the soup is the liquid state that is on the mantle, where are lithospheric plates. So these crackers are our lithospheric plates, and whatever the soup is hot, so it's constantly heating up and pushing our lithospheric plates and making them drift apart or come closer to each other. So this is because of the conventional currents inside the mantle. These make the lithospheric plates or tectonic plates to move slowly. Okay. Children, in this diagram you can see that the black line is the crust and below there is the mantle, which is in a liquid state. Now this, because of the heat, what happens, convection currents takes place, and you must have learnt it in science what a convection currents. When the water boils, the bubbles go up, they come down. Okay, this continuously happens till the water begins to boil. So this kind of convection currents are taking place in the mantle, and then these push the crust, which is broken up into plates, which are called as lithospheric plates or tectonic plates, to drift apart. Okay, and that happens in a very slow manner. It's not that it happens they drift apart very fast, very slowly. We don't feel that the our crust is moving. It happens in a very, very slow manner, and that explains the theory of tectonic plates, and because of this the continents have drifted. So I hope you have understood the theory of continental drift and the theory of plate tectonics. Children, let us recap what are lithospheric plates. They are actually the earth's crust that is broken up into small pieces, okay, which are called as lithospheric plates, or they are also called as tectonic plates. They are almost 12 major broken features. Then they are flat, irregular shape. They are not in a regular shape. They may be all kinds of shapes, and these plates move very slowly because of the movement of the molten magma. And what kind of currents is this? Convection currents that we see, which makes these plates to move. And the movement of these plates causes changes on the surface of the earth. What all kinds of changes takes place on our earth because of the movement of the plates. So you see, children, what are lithospheric plates? They are large rigid slabs of solid rock moving on the molten magma. Children, our earth is the only planet where living things can survive. It is the only planet which has water. But has our earth remained the same since ancient times? No. Our earth has been constantly changing, and that is why we call our earth as dynamic. Constant changes take place. So let us find out what are the changes that have taken place on our earth. Children, we have learned two theories. One was of the theory of continental drift, and the second was the theory of tectonic plates. According to Alfred Wegener, the theory of continental drift, he proved that earlier all the continents were joined together to form a supercontinent called Pangaea. And due to the movement of the lithospheric plates, as you know, the lithospheric plate is broken up into pieces, and due to the circular motion of the magma inside our earth in the mantle region, it makes this lithospheric plate move, and due to that movement the continents have drifted apart and moved all out to form our present day continents and oceans. So we can divide these movements into two parts. Okay, there are two types of forces which act upon the earth and brings about changes on the earth. One we call it as an endogenic force, and the other as an exogenic force. Now what is endogenic? Endogenic means what is happening inside our earth. The forces which are acting inside our earth is called as endo. Endo means inside. Okay, origin. Genic means origin, and the air forces which are originate inside our earth. And exogenic means forces which are generated outside or on the surface of the earth. Okay, exo means outside. So now, due to the internal forces, whatever the forces are acting inside the earth, there are two types of movements will take place. One, which is sudden, which cannot be predicted. This leads to natural disasters like earthquake, volcanoes, landslides. And some are diastrophic forces, that means very slow movement. We don't come to know, but this slow movement creates new kind of features on the earth, like building of mountains or rift valleys. This is happening due to the internal forces which are working inside, due to the continuous circular motion of the molten magma. Now, exogenic forces which are happening on the surface of the earth because of weathering, okay, when rocks break up into pieces, erosion, okay, and deposition by agents like which causes weathering, erosion, and deposition, river, wind, sea waves, and glaciers, okay. Because of this weathering, erosion, and deposition, various kinds of features are created on the surface of the earth. So we are going to learn these features as we go ahead in the chapter. Children, I just told you about the endogenic forces, forces which act inside the earth's surface, okay. And due to this, there can be sudden the things happening on the earth. That means they can lead to earthquakes, volcanoes. They come without any warning. They are natural disasters. There's another force called diastrophic force, which means it happens very slowly, and this also is generated by the endogenic force, that forces which act beneath the earth's surface. And what is that? Because of the constant circular motion of the molten magma on which our lithospheric plates are moving, okay. So this results also in bringing about changes on our earth. Now, diastrophic forces can either bend rocks, okay, or they can break rocks. Children, due to the result of bending of rocks, what is created? Mountains are created like the Himalayas, and due to breaking of rocks, what is created? A valley or a trench is created like the Mariana Trench. Children, endogenic movements can be vertical. Can you see one going down, the other going up? Or it can be horizontal. They are sliding past each other. So there are two types of endogenic movements which is working under the inside the earth. They are vertical movements or horizontal movements. Children, the vertical movements inside the earth's surface, where one portion of the lithospheric is going down, then the other is going up, it causes either the earth to be lifted or sinking. The earth's crust either gets uplifted or sinking. So one you can see is uplifted, the other one is sinking due to the vertical movements of the lithospheric plates, okay. Children, due to the vertical movement of the lithospheric plates, what happens? Either the earth gets lifted up to form mountains, or it sinks down to form valleys. Now this movement is very slow, and that is why they are called as diastrophic forces. They are not sudden, just not like the earthquake or volcanoes or landslide, which happens suddenly without any warning. Okay children, now let us look into the another force which acts on the earth, that is called as exogenic force, which are acting on the surface of the earth. Endogenic was inside the earth's surface. On the surface of the earth, which are the forces which are acting? There are three forces which are acting: weathering, erosion, and deposition. Now let us look into what is weathering. Weathering is the breaking of rocks on the earth's surface by agents like wind, water, and ice. When the rocks break up due to these three factors: water, wind, and ice. So children, you see, weathering breaks up the rocks, okay. Now we are showing a picture of a hammer, but it's not the hammer, but agents like wind, rain, okay, they break up the rocks. Now how will you say wind? Wind keeps on battering the rocks, and finally the crumple into small pieces. The entire rock gets broken up, and constant water is splashing on these rocks, which leads to certain cracks. And at ice also is one of the factors. When water gets into the holes of these rocks, when it freezes, then it expands, okay, and then ice works like a wedge, and this hole gets widened, and finally the rocks break up. So due to weathering also changes, we can see the changes happening on the earth's surface. Children, another force that is acting on the earth's surface is erosion. What is erosion? Carrying away of the broken rocks by different agents like water, wind and ice. Whatever is broken, the water carries it away to another place. Winds again further erodes it and makes into fine particles. Even glacier erosions takes place, ice erosion takes place. Ice, when it flows from the mountain, it scrapes the mountain, and lots of rocks are broken and taken from one place to another. So another factor which works on the surface of the earth and brings about all kinds of changes on the earth is erosion. What was the first one? Weathering, and then erosion. Children, another factor which works on the surface of the earth, or forces which work on the surface of the earth, is deposition. Now whatever has been eroded has to be deposited somewhere, yes, so that creates new kind of land features on our earth, like sand dunes. If you have seen sand dunes on the desert, what happens in the desert? When the wind blows, the sand also blows along with it, and then as the wind speed reduces, it deposits all that blown wind into another place. Okay, that's why we call sand dunes as shifting sand dunes. They shift from one place to another. So whatever has been eroded gets deposited somewhere else, which leads into a different formation on the earth's surface. So we see three forces acting on the earth's surface, which are called as exogenic forces. Which are the three? They are weathering, erosion and deposition. And which are the agents which cause weathering, erosion and deposition? It is wind, water and ice, and we'll look into the formations by this in our next video. Children, in our next video we'll learn more about the results of the endogenic and exogenic forces. We'll learn about earthquakes, volcanoes, all kinds, how the river makes all kinds of landforms, okay, valleys, all that we will learn in our next video. What are the various changes which take place on our earth's surface due to the endogenic and exogenic forces. So children, let us recap what we have learned in this video. We have learned that Alfred Wegener's theory of continental drift proved that millions of years ago all the continents were joined in a supercontinent which he called as Pangaea. And due to the movement of the lithospheric plates, the supercontinents broke up into large land masses that drifted away. Okay, now these big land masses became our continents, and the water collected between the land masses form our oceans. Now the lithosphere, as I told you, consists of a number of plates which are called as lithospheric plates or tectonic plates, and these are floating on the molten magma, which is constantly in a circular motion due to the convection currents, isn't it? Okay. So next also we have learned that these movements can be endogenic or exogenic. Okay, what is endogenic? Forces which are acting inside our earth, and exogenic is forces which are acting on the surface of the earth, that means outside the earth. Now endogenic forces can be sudden. I've told you sudden means either earthquakes, volcanoes or landslides that will lead to natural disasters, and diastrophic means very slow kind of changes which take place, leading to building mountains or valleys. Now forces which act on the surface of the earth are weathering, erosion and deposition due to the agents of wind, water and ice. So in our next video we are going to learn what are the results and changes that takes place on our Earth's surface due to endogenic and exogenic forces. Thank you.